Well, welcome to problem 6.26 part A, where we're being asked to determine by the method of sections the forces in members BC, GC, and GF. Method of sections. Very quickly, I don't want to use that color. So we're looking at BC, GC, and GF. Regardless of whether we take the left section or the right section, actually, if we take the left section, we wouldn't have to calculate for the reactions that support at points E and point H. So let's do that. We'll work just on the right-hand section. Give me a minute to do a free body diagram. I'm sorry, we're going to work on the left-hand section. Give me a minute to do the free body diagram, and away we'll go. Be right back. All right, so I have our free body diagram for our left-hand section over there. One thing that we still need to do is I'm noticing that member GC is at a diagonal. So because it's a diagonal, it means that we need to pull out the X and the Y components. So it looks something like that. So this angle will be the arctan of opposite. So we're looking at this angle right here. Opposite divided by adjacent. So arctan of 8/6. Which is 53/13. Oh, we've seen that a couple times. 4/3 is the same, that's why. All right, so GC, this be GC sine 53/13. This is GC cosine 53/13, and I think we're ready to go. Let's take a look what we've got going on here. So, well, so there's only one other Y component. So there's the external force at point A, and then the Y component for GC. So we could take the summation of the forces in the Y direction, -4 kips plus GC sine 53/13 is equal to 0. Add 4 kips to both sides and divide both sides by sine 53/13, and we get that GC is equal to 4 kips divided by sine 53/13. Let me get my handy dandy out. 4 divided by sine 53.13. Oh, I get 5. That's a bonus. 5 kips. Go down here. So GC is 5 kips. It came out as a positive number, which is an indication that I have the direction correct. It is pulling the reaction at pin for GC is pulling away from the pin, which would be a reaction to the member being in tension. Okay, so that's 5 kips. If we take the moment about point G, that would allow us to get BC. So let's do that. Let me change back to different ink color. The moment about point G. GF not a player because it goes directly into G. GC not a player, goes directly into G. 4 kips is a player with a perpendicular distance of 6 feet. BC is a player with a perpendicular distance of 8 feet. Let's take a look at the rotation. We're going about G, rotating about G. The external force at point A causes a counterclockwise positive rotation. the internal force generated at BC causes a clockwise negative rotation. So we've got 24 kip feet minus BC times 8 feet. Subtract 24 both sides, divide both sides by -8. Get that BC is equal to 3 kips. Again, I have a positive number, which indicates that I have the correct direction assumed. Now we can just I think we can just take the summation of the forces in the, oh, I don't want to use that. There we go. Summation of the forces in the x direction. So let's see what we've got. We've got positive 3 kips. We've got GC times cosine 5313, also in the positive direction. So 5 cosine 5313 minus GF. 2, that's it, 3 of them. All right, solving for GF. GF is equal to, I get it as 6 kips. Oh, we forgot to discuss compression or tension on BC. So BC is at tension and GF is at compression. There we go. Sorry about that. Okay, that's 6.26a. We were not asked to solve, well, the book asked us to solve B, but the assignment was just to solve part A. So that's it for this one. Please provide comments. Positive or negative feedback is always appreciated. You can provide that in the comment section. See you in a little while.